we are going to get started. So if you did not join us for Monday, we were working in Unit 2, Part 1. So we're going to go through some of the study questions, and we're going to post those questions today. Let me put my phone on vibrate. And we're going to get started with those. So let me share my screen. Can you guys see my screen? Is that a yes?
Yes.
All right, cool.
Yes.
All right, so the learning objectives that we were working on Tuesday, no, I'm sorry, on Monday, were distinguishing between mixtures and pure substances and classifying pure substances as elements or compounds, identifying the symbols and names of common elements, identifying the 3 states of matter and describing their properties, distinguish between the chemical and physical properties of matter, differentiate between chemical and physical changes. And we left off the last one, and we're going to pick that up when we meet on Monday. Identify a chemical change as a chemical reaction. Right, so let's take some practice on identifying or distinguishing mixtures and pure substances and classifying pure substances as elements or compounds. Let me show the chat so I can follow along, make sure you guys are answering with me. All right, so let's take a look at the left of the screen. Identify each of the following as a pure substance or a mixture. Pasta noodles, what do we have? Pure substance or mixture? Good job, mixture. What about aluminum foil? What do we have for aluminum foil? Yes, it's a pure substance. How about helium? What do we get for helium? Yes, pure substance. And air. Right. Ooh, some of you put pure. Remember Monday's lecture, we went through this whole simulation to show that air was a mixture. All right, let's take a look at the right side of the screen and let us identify the following. Oh wait, before we go on, I have a question here. If any of these are mixtures, are they homogeneous or heterogeneous? So let's look at A, pasta noodles. Is that a homogeneous or a heterogeneous mixture? I've got, it's about half and half. Okay, I'm not talking, it's the garbage day. I'm sorry guys, we meet on garbage days in my neighborhood. So the garbage truck comes along right in the middle of our class. Well, okay, let me make this the regular pasta noodles, not wheat pasta or vegetable pasta. How do we know? Yes, much better, homogeneous mixture, because it's consistent throughout. What about air? Air, would it be homogeneous or heterogeneous? Right, air would be air, can we see the difference in air? Can I look in air and see that there are carbon dioxide molecules there and there are oxygen molecules there? No, we can't see the difference. So air is going to be a homogeneous mixture. All right, let's go over to the right side of the screen and let's identify each of the following as a homogeneous or heterogeneous mixture. Why does the garbage truck have to be so loud? Why? So hot fudge sundae. Is that heterogeneous or homogeneous? Hot fudge sundae.
Hetero.
Yeah. Oh, I forgot to put those in. All right, heterogeneous. What about body lotion?
Homogeneous.
For the most part, it's going to be homogeneous. What about sugar water? Yep, homogeneous. And what about peach pie? Cool. You know, what I miss about being in the auditorium, because we would have been meeting in the big auditorium on the first floor of Hunter, is that when I ask these questions, people are yelling them out I'm up on the stage and they're yelling about homo, hetero. I kind of miss all of that. Anyway, moving on and on. Cool. All right, so a white solid with a melting point of 730 degrees is melted. So what are the things that help us to solve this problem? The melting point of a solid. The next thing is when electricity is passed through it, we get a liquid, a brown gas, and molten metal. And then it says neither the metal nor the gas can be broken down into simpler means. So what do we get? Well, we know that the white solid is what? What can we say is the white solid if we run electricity through it and we, right, it would be a compound. So what do they mean? They melted a solid and from that liquid, they pass electricity through liquid. So the white solid is a compound. Then we have the molten metal. What is the molten metal? Is it gonna be, right, it's gonna be an element because it says that neither the metal nor the gas can be broken down by anything simpler. So that means that they must already be in their elemental form.
Yes.
So they are both elements. Okay? All right. All right, so we have our first question that, here we go. So the answer is, folks, the only one that's a compound is table salt, and the majority of you got that correct. All right, here's our next question. So the answer that we get here is we've got sodium metal, solid sodium chloride, and sodium chloride dissolved in water. The answer is we're looking for mixtures. So sodium chloride dissolved in water is the mixture. Sodium metal is what, guys? What would that be?
An element.
Element.
It's an element, and it would be a pure substance. And what about D? That says sodium metal and sodium chloride are mixtures, but what should that say? Sodium metal and sodium chloride are not compounds, but what would be, yes, pure substances, right? So to classify the two of those together would be a pure substance. The metal is an element, whereas the sodium chloride is a compound. All right, another question. Let's see. And what do we get for our answer, folks? Which of the following is a homogeneous mixture? Yes, lemon flavored water, D. All right, so let's do some practice on our next learning objective. Identify symbols and names of common elements. All right, whip out your periodic table. There's a great periodic table online called ptable.com. It's got great information. So let us write the correct chemical symbols for each of the following elements. What should we write for iodine? Make sure you're writing it properly. There are no, everything, the uppercase and lowercase is really important in chemistry. So if you put lowercase I, you will be marked incorrectly on an exam. All right, so the answer is I, capital I. What about B for iron? Yes, capital F, lowercase e. What about magnesium? Capital M, lowercase g. And what about zinc? Oops, some of you, zinc is a two-letter symbol, capital Z, lowercase n. What about nitrogen?
Capital N.
All right, so I see a couple of you wrote N2. I didn't ask you what was, I didn't ask you for how you present nitrogen. right? I'm asking just for the chemical symbol, and the chemical symbol would be N. N2 represents the molecule. So if you were to write nitrogen as a part of a chemical equation, you would definitely have to write N2 because that is how it's found in nature. But right now we're just looking at the chemical symbols for nitrogen. All right, let's look at the right-hand side. Let's give the name. So N2 is not the chemical symbol for, well, the elemental symbol for nitrogen is N. That's what we were writing here. So, all right, A, phosphorus, correct. What about B? Aluminum. What about Mn? Mn, manganese. How about H? Hydrogen. And E we have is potassium. Good job. Question. My screen is freezing. Which, if any of these elements are necessary for human life? Which of these are necessary, guys? Actually, all of them. We have a need for all of these elements. Just depends on the concentration at which we need them, but each and every one of these elements are necessary for human life. Yep. Some of them are micronutrients and some of them are macronutrients. The ones that we need in large quantities, because phosphorus helps to make up DNA. Hydrogen also is a part of every single compound. Because you are a living thing, organic compounds contain hydrogen and carbon. So almost everything that makes you up is hydrogen and carbon. All right, moving on. Let us represent the following. Let's take a look at the difference between elements and compounds. You can't hear me. Can you guys hear me?
Yes.
Okay. All right. So which of these represents elements and which of them represent compounds? Let us see. What does C represent? C, the letter C.
Element. It's carbon.
Yep. C is an element and the element is carbon. What about Cu?
Copper.
Okay, copper, and it is an element. What about Hi?
Compound. Compound.
It's a compound. It's hydrogen iodide.
Iodide.
Yes. What about Bn?
Compound.
Okay. In. Is that a compound or an element? What do we have? Yes, we have, that is an element. It is indium. And what about HBr? What do we have there? Is that an element or a compound? HBr, what do we have? I wonder if my Zoom froze. Can you guys still hear me? Because I'm not seeing any chats. I'll just move on along. HBr is a compound and it is helium, it's hydrogen bromide. So here we go with our next question. Our answer is C, bromine. So what is the element for the letter B? That is boron. Be is beryllium and Bi is bismuth. Okay. Next question. And the answer is silver. What would be the symbol for gold? The symbol for gold is going to be AU. The symbol for aluminum is going to be AL. And the symbol for Americium is going to be AM. Let's take a look at what the, okay, am I back on? Let's take about what the answer, take a look at what the answer is. You have to count the number of carbon atoms. So the answer is C, 3. Why? Because I've got a carbon in the parentheses and there's a 2 on the outside of the parentheses. So that means that there are 2 carbons there plus 1 on the outside. How many hydrogen atoms would there be? Yes, there would be 8 because I've got 3 times 2 is 6, 7, and 8. Great, here goes the next one that I just gave to everyone. All right, so we'll skip this one. Which of the following is an element? How do we know that B is the actual answer? The second letter is a lowercase. So that's why we know that, that this is an element. The rest of these are, sorry guys, I froze for a moment. The rest of these are compounds. All right, stop typing in because it's slowing up, it's locking up my, the rest of these are compounds. CuO, we've got a copper is an element, and then oxygen is an element. For C, nitrogen is an element, oxygen is an element, and then K, potassium is an element, and fluorine is an element. All right, so let's take a look at identifying the states of matter. On the left, identify each description as that of a solid, liquid, or a gas. It has a definite volume, but takes the shape of the container. What do we have, a solid, liquid, or a gas? Yep, it's a liquid. The particles are moving rapidly. This one is tricky. A gas or a liquid, because particles and liquids are moving pretty fast as well. Rapidly is, what's the word I want to say? Is relative. Rapid to what? Right, so the particles within a liquid are also moving pretty fast. Its particles fill the entire volume of a container. That's going to be a gas. Its particles have a fixed arrangement, letter D. Solid, yes. And its particles are close together, but moving randomly. What do we get for E? The answer for E is a liquid. Amorphous means no shape. And time is up. And our answer is a gas. Gases are the most compressible state of matter. All right, now we're going to take a look at identifying and classifying matter based on their physical chemical properties. I don't know what's up with Zoom. This is not cool. All right, so the last topic that we covered before class was over on Monday was chemical and physical properties. So let's take a look at the left side, the left side. of the screen, and let's classify things as, what you call it? Okay, let's pause for a moment because I see that there are questions about the last, about the last slide. All right, so compressible means that I can squeeze into a small space, right? Remember, gases are all over us. We can do all of this to gas. Why? Because there's lots of space in between. So there's plenty of space in between every gas particle, and that's why we can compress them. Remember, I said to you the other day that we can take all the oxygen in a room and put it into a gas cylinder. That's why it's always labeled high pressure, right? Exactly, Austin. It's because all those gas particles, they want to bounce around and be free, but they end up being a liquid inside the gas cylinder. So solids, can somebody compress you? No, they can't. You get squished, you die. Liquids, if you try to squeeze liquids, the liquids move out of the way. That's just like, have you ever went swimming and did a belly flop? Right? A belly flop is what happens if you try to press a liquid, right? So you go into the pool. Okay, well, belly flops are pretty painful. You jump into the pool like this, and because the water is not compressible, the water pushes its way out, and you are just, and you end up hurting yourself, right? So yeah, I used to swim. All right, so solids, a solid compresses the liquid in this case. So a liquid would compress into a solid, but if you were watching the simulation that we did the other day, the top popped off of our simulation when we tried to put too much, too much pressure. So yeah, it's a solid compresses the liquid in this case, because you're hitting yourself with the water. So it's because the solid and the liquid can't share the same space, and the liquid can't be compressed, which is why the water splashes and you actually end up hurting yourself. All right, so now let's go back to our chemical and physical properties. All right, so ice melting in the sun, is that physical or chemical? I kind of already showed the answer. That would be physical. Excuse me. Copper metal is shiny. That's going to be physical. Paper can burn. That would be chemical. A silver knife can tarnish. That would be chemical. And a magnet removes iron particles from a mixture. That would be physical. We can't, the magnet is just physically pulling the metal out of a mixture. All right, let's classify each of these changes as a physical or a chemical process. Burning a candle. We're burning a candle. That word should tell you that a chemical reaction is occurring, and that's going to be a chemical process. Ice melting on the street. Please don't just post one word at a time. You're slowing down my Zoom screen. Ice melting on the street would be sorry about that. I'm back. Ice melting on the street would be a physical process. So burning a candle is different from melting. Melting a candle would be physical. Burning the candle is chemical. Toasting a marshmallow would be chemical. Cutting or slicing pizza, that's going to be physical. And iron rusting in an old car, that is going to be chemical. We've got a few more questions. I think this might be our second to last one for today. And our answer is, it's asking what is not a physical property. The only one that's not a physical property is flammability. That means the ability to burn. All right, last question for today, and we will be done. Answer is, see you guys. See you guys later. No, see you on Monday, and I will definitely let you know how we're going to meet. And have a great weekend. Have a great weekend. Bye, guys.